and find the area between these two curves, it's always best to get a graph of what the two curves look like in order to have a sense of what we're doing. So x minus 12 in absolute value, that is a shifted absolute value function over to 12. And then the other function, x over 2, is just a line with slope 1/2. And it's roughly like that. So we're looking for those two intersection points. That would be our first step. We need to remember that the absolute value function is piecewise defined. So this will equal what's inside the absolute value if what's inside the absolute value is greater than or equal to 0, which will mean x is greater than or equal to 12, and it will be equal to the opposite of what's inside the absolute value if what's in the absolute value is negative, which translates to x being less than 12. So now let's go ahead and find our intersection points. So when we're to the left of 12, so if we want to find the intersection point on the left there, we are going to set x over 2 equal to, let's see, to the left of 12, that means negative x plus 12. And we can multiply both sides by 2. We can add the 2x to both sides and then divide by 3, and we will get that x is going to be equal to 8. So this point right here is going to be 8, 4. And then let's go ahead and find the other intersection point. So the other intersection point, we're going to set x divided by 2 equal to, let's see, we're greater than 12 over there, so that's going to have a function value of x minus 12. Once again, we can multiply by 2. And this will end up giving x equal to 24. So this point over here will be 24, 24 divided by 2 is 12. So those are the two intersection points. And our goal then is to find this area in here. We are going to have to subdivide this region into two regions. We'll split it right down the middle here. Maybe I shouldn't call that. We'll split the absolute value down the middle right there. And so we are going to have the following setup. We are going to have that the area is equal to the integral from 8 to 12 of the upper function minus the lower function. And we are to the left of 12, so to the left of 12, that lower function is negative x plus 12. So that's going to find the left-hand portion of that area. And then we're going to have to add the integral from 12 to 24. Once again, the upper function minus the lower function. The lower function to the right of 12 is x minus 12 dx. So that's where we're at. Let's go ahead and simplify this a little bit. So we're going to integrate from 8 to 12, and inside the parentheses, excuse me, we're going to distribute that minus, so we're going to get plus x, so that will be x over 2 plus x, which is 3/2 x, and we are going to have minus 12 dx plus integral 12 to 24. And same idea here. If we distribute that minus, we're going to have x over 2 minus x, and so that's going to give us negative x over 2. 1/2 x minus x is negative 1/2 x, and then we're going to add 12. We'll perform our integration here. Add 1 to the exponent, divide by the new exponent. This will go from 8 to 12. Similarly over here, we add 1 to the exponent, divide by the new exponent. This will go from 12 to 24. And so at this point, we just have to do our substitutions. So we are going to have 3/4 multiplied by 144 minus 12 into that x gives 144. And then we subtract off the antiderivative at 8, so that's going to be minus 3/4 times 64. And then minus a minus is plus 12 times 8. And then we have all the other stuff from the second antiderivative. We'll have negative 24 squared. We'll figure that out in a minute. Divided by 4 plus 12 times 24. And then we subtract off. So subtracting off a negative is going to be plus 144 over 4. Subtracting a positive, minus 144. So then we just have to simplify that expression.